All right, so when you are calculating probability, what are you looking for? A ratio. What kind of ratio? Successes over what kind of outcome? So success.
Over total?
Is that how you spell successes?
Yes.
Let's just do success over total outcomes. Yes. So you're looking for how many successes do you have divided by the total outcomes. So you are correct. It is a ratio. All right. Probabilities are assigned to an event. For example, what's the probability that you will get 6 hours of sleep in a typical night? Do you call sleeping an event? Maybe, maybe not. But that's a formal way to just name an activity that you're finding the probability of. Events that are certain to occur are assigned a probability of what? 1. Okay, let's talk about that. Where does the 1 come from? If something's certain to occur,
There's only one outcome.
there's only, not necessarily there's only one outcome, but it's 100% that it's going to occur. For example, you will receive a grade for pre-calculus. What is the probability that everybody in this room is going to receive a grade, a year-end grade for pre-calculus?
100%.
100% that you will receive a grade, okay? In probability, we take the percent off. And how do you change percent? How do you get rid of divide by 100, which moves the decimals and places to the left, okay? Events that cannot occur are assigned a probability of 0. Good. Okay. What is the probability that you can travel back in time? 0. That cannot occur. It would be exciting if we could. Probabilities of events are expressed as numbers ranging from 0 to 1. Exactly. Good. The closer a probability is to blank, the more likely it is to occur. 1. Yes. The closer a probability is to 0, the less likely it is to occur. Okay. Questions on our intro to probability. So goal 1, we want to compute something called empirical probability. The empirical probability of event E is denoted by P parentheses E. This is not P times E. This is P of E, or you read it, the probability of event E. E could represent any event. Okay. So our formal definition, the probability of an event, is the number of successful outcomes over the total possible outcomes. Okay? So when women turn 40, their gynecologists typically remind them that it's time to undergo a mammography screening for breast cancer. So this is real stuff. When you all are 40, or maybe by the time you're approaching that age, your gynecologist may, that's your female doctor, your gynecologist may suggest that you start having a mammogram even earlier than that. So the data in this table are based on 100,000 U.S. women ages 40 to 50 who participated in a mammogram screening. And so you understand this table, because I think there was some confusion earlier. A positive mammogram means something showed up on the scan, and your doctor would call you back to do further testing. That's what that means. A negative mammogram means nothing showed up on the scan, nothing out of the ordinary. So, of women, these 1,000 women, or 100,000 women, of the ones that did have breast cancer, 720 had a positive mammogram, something showed up. 80 had a negative, meaning nothing showed up on the mammogram. Of the 100,000 who did not have breast cancer at all, 6,944, something showed up on the mammogram where it tested positive. Negative, 92,256, nothing showed up, so it tested negative. Does that make sense? Find the probability that a woman aged 40 to 50, this table gives us age 40 to 50, has a positive mammogram. So what would we consider, what's the successful outcome, or what's the outcome we're looking for in A? We're looking for the probability of? Positive over total, yes. So we're looking for the probability of a positive mammogram. So how many positive mammograms do we have? 6,944 plus 720. Why would we have to add 720? That's right. They're both in this positive mammogram row. So 720 plus 6,944 over, how many total mammograms were there? 100,000, yes. So that's 7,664 over 100,000. Is that a number between 0 and 1?
Yes.
Yes, it is a number between 0 and 1. You're welcome to leave your answer as a fraction, or you can divide, and for a decimal, you would get 0.076. I'm sorry, 0.077 if you round it. A great thing to do every time you find your probability is double check that it's between 0 and 1. If it is not between 0 and 1, that tells you you've made a mistake. Okay? Let's look at B. Among women with breast cancer, find the probability of a positive mammogram. So, among women with breast cancer, find the probability of a positive. Didn't we just find the probability of a positive in A? What's the difference between what question A is asking and what question B is asking? This one, our total is just going to be the women with breast cancer. That's exactly right. So we'll look in the middle column. How many women total had breast cancer? 720 plus 80, so 800. Will 800 be our numerator or denominator? Denominator. Good. Now, how many of those tested positive? 720, yes. If we change that to a decimal, 720 divided by 800 is 0.9. Is that between 0 and 1? Yes. All right, let's finish up with C. Among women with positive mammograms, find the probability of having breast cancer. What's going to be in our denominator now? The number of positive mammograms. It says among women with positive mammograms, so this is our denominator, find the probability of having breast cancer. Notice each time, whatever followed probability of was in our numerator. So how many women total had positive mammograms? Yes, when we add these two numbers, 7,664. And how many actually had breast cancer? 720, yes. So what's that? That is a probability of 0.094. So you can see that out of the positive mammograms, the actual probability of the positive mammogram really being cancer is very low.